it shouldn't give us a way different answer, yes.
For formula number one,
Mm-hmm.
can you have the same number of resistors as the total or the actual resistors? Power, I guess? Like 10 divided by 10?
Yeah, you could. That would be one ohm of resistance. It could be, yeah, it could be. Mhm. It could possibly have that question in a test. And the thing here is that sometimes the numbers don't make sense for us, right? It doesn't really make sense that that I'm gonna have a larger number or a smaller number being divided by a larger number. But here, it doesn't really matter if it makes sense or not. You have to follow the rules, and whatever answer you get, that is something that you should be able to measure with the multimeter when you're looking at your circuits. So you guys are gonna see a lot of things that doesn't really make sense, but if you follow the rules and your circuit is balanced, it's just physics, right? It's physics, and all of this is theory. And when we do all of this math, this is something that already is calculated, and this is a design circuit. Now here, in some cases, I'm gonna be making up some numbers, but I can't forget, like I can go ahead and just make up resistor values and also put amperages, and my circuit is not gonna be balanced. I have to make sure that it makes sense in theory, right? So if I'm working with a series circuit or a parallel circuit, I'm kind of familiar with these types of circuits where I can give you an example like this, but I won't be able to make up the amperage without making sure that mathematically it makes sense for you guys. Okay, so let's go ahead and apply or look at formula number 3. Now, formula number 3 is a little bit confusing, but let's go ahead and start. Okay, so formula number 3 tells us that if I want the total resistance of the circuit, and I have more than 2 resistors, but I have all of the values of the resistors, and I want the total resistance, I have to use the reciprocal. So it would be 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3 plus 1 divided by R4, and however many resistors we have. So if we have more than 3 resistors, but we actually have the resistor values, we have to have the resistor values, we would use formula number 3 to be able to solve for the total resistance. Okay, so let's see that applied. Okay. So in this case, I can't use formula number 1 because all of the resistors have a different value. I can't use formula number 2 because I actually have 3 resistors. So here I'm going to use formula number 3 to be able to get the total resistance. So this is my voltage total. This is the pressure being applied to the circuit. Now here I'm going to go ahead and put R total equals 1 over 1 divided by 5 plus 1 divided by 20 plus 1 divided by 4. Now go ahead and pay attention before you guys start writing everything down. Go ahead and pay attention on how I'm going to go ahead and solve this. So I'm going to go ahead and continue to insert this one because sometimes my students will forget this last step. So I'm gonna start with dividing 1 by 5. So our total equals 1 over, and now I'm going to take 1 divided by 5. That's gonna give me 0.2 plus 1 divided by 20. That's gonna give me 0.05 plus 1 divided by 4. That's gonna give me 0.25. Alright, my next step would be our total equals 1 divided by the sum of these three. So I have to add them up. So in this point, I have to add these three values. So it's gonna be 0.25 plus 0.05 plus 0.2. That would give me 0.5.
Yeah.
So our total equals 1 divided by, let me go slowly guys, okay? Because there's a lot of students that are not as good as math with you guys, so I need to go a little bit slow, okay? So 1 divided by 0.5 will give me 2 ohms of resistance. And this is how we insert all of our values into this formula. So the first step would be to solve for these, right? So I'm gonna go ahead and divide. 1 divided by 5 gives me 0.2. 1 divided by 20 gives me 0.05. 1 divided by 4 gives me 0.25. As you can see, I continue to insert my 1 here because I have to go in order. After I get these values, I add them up. So that would be 1 divided by 0.5, and that would be the last step. And now I can get my total resistance of 2 ohms. So this would be our total equals 2 ohms. And that's how we use our formula number 2. Formula number 3. When we have more than 3 resistors, then we have the values. If we're missing any of these values, we can't use this formula anymore. We have to use formula number 4, but we'll get to that next. So in formula number 3, you have to have more than 3 resistors, and you have to actually have all of the values for resistors in order to be able to insert it there. Now here, I can go ahead and use Ohm's law, right? I remember that my voltage is a constant value, so I can insert 40, and 40 volts to all of them to be able to get the amps and to be able to get the power of each one of these resistors. But I like to finish my totals when I have enough values. So in order to get my I total, I'm going to take 40 divided by 2, which gives me I total of 20 amps, and power total would be 40 times 20. That would be 800 watts. So I'm done with my totals. Now I can go ahead and solve for resistor number 1. So it's going to be 40 divided by 5. That's going to be 8 amps. 40 divided by 20. That's going to be 2 amps. This is going to be 10 amps. And I can go ahead and add them up, right? 10 plus 8 plus 2 gives me 20 amps. So, okay, we're doing it right. So now I'm going to get my power. 40 times 8 gives me 320 watts. 40 times 2 gives me 80 watts. 40 times 10 gives me
400 watts.
400 plus 80 plus 320 should give me 800 watts. Alright, any questions? This is not as easy as series, right? You have to do a little bit more thinking, and you have other formulas that you have to use. Now, we could skip the formulas altogether. If we have enough values, we can go ahead and just skip the formula. So let's see if we can find a circuit where we can actually skip the resistor formulas and we don't have to use them at all.
Question.
Uh-huh.
You said that formula 3 is used when you have more than 3 resistors.
Mm-hmm.
In this case, we have 3, right?
Mhm.
1, 2, 3.
3 or more.
Oh,
Three
three
or
or
more.
more, not
Three or
more
more.
than 3.
No,
Three
three
or
or
more.
more, yes. The formula number 2 is for 2 resistors only. So that would be the max, or the only way we could use formula number 2. And for formula number 1, we could have 15, 20 resistors, but they all have to have the same value in order to be able to use it.
Got it.
They all have to be 5 ohms, all of them. They all have to be 24 ohms, all of them.
All of them.
If you have one of them that has a different resistance, you can't use
Then
it.
we have to use
You have to use formula
formula
number 3.
2 or 3.
Formula
depending
number
on the
3.
resistors.
Only 3. Let's say, for example, if you have 10 resistors
Mhm.
and 9 of them are 10 ohms of resistors, of resistance, but one of them is 24, now you have to use formula number 3.
No, thank you.
Okay? Okay, so for this example, we have 2 amps here, and we have 1 amp here, and we have 6 volts. That's our E total. So we need to solve for our amp total, our resistance total, our power total. Jesse, what would you do here to be able to start this operation?
Sorry,
It's okay, if you don't know, you just let me know you don't know, you're not sure. Not sure? Rogelio? No? Not sure? Leo?
Well, we have 6 volts across the board, and we got the amperage, so the next thing to do would be to solve for the resist for the ohms. So to do that, we would divide the voltage by the amperage, so 6 divided by 2 would be 3 ohms for resistor number 1.
Alright, so you would apply the 6 volts to each one of them. Right?
Yes.
Alright, that's good, that would be the best step. So you guys are gonna see that if we follow the rules for, our parallel circuits, sometimes we're gonna skip all the formulas altogether. We're just gonna use Ohm's law. So in this case, Leo took 6 volts here, so now you have 2 values here, 2 values here, you have enough, right? To be able to solve and just use Ohm's law,
Yeah.
right? But what else could we do?
example number 2.
We could use, we can't really use it because what they gave us was amps. So we don't really know what is the resistor of each one of them, so I can't use that one at this. I could, yes, correct. You can take 2 plus 1 and that gives me total of, correct, yes. So you have to remember what happens to amperage in this type of circuit. The amperage adds up, right? So we can do 2 things. We take the voltage and we apply it to each one of them, or we take these 2 and we add them up, right? And we have the total amps and the voltage is being applied. So do we have enough values there to solve for everything using Ohm's law?
Yeah.
Yeah, right? Do we have to dive into the formulas there?
No.
No, but it is because you are paying attention to what are the rules, what applies to each one of the circuits. So now here, you just need to take 6 divided by, or 6 times 3 gives me how much?
18.
So it's total 18 watts. And 6 divided by 3 gives me
Two.
2 ohms of resistance. Now that's the total resistance of the circuit. 6 times 2 gives me 12 watts, and 6 divided by 2 gives me 3 ohms of resistance here. 6 times 1 gives me 6 watts, and 6 divided by 1 gives me 6 ohms of resistance. Now these two have to be larger than the total resistance. Now, if you guys wanted to use any of the formulas, for example, our formula number 2, to be able to verify that you did your math, you can do that. So it would be 3 times 6, and then 3 plus 6. How much would that give you?
哦
Does it work?
Yep.
It works, right?
Yeah.
So sometimes we can go ahead and skip the formulas altogether if we remember what are the rules for each one of the circuits that we're solving for, and we remember what adds up, what divides, what gets multiplied, and using our Ohm's law. Yes?
So in order to find the resistance total, like, to like double check your work, you would have to divide 6 by 3?
You don't have to. I do, like when I'm doing math like that. When it's a simple circuit like this one, no, but when you have like 20 resistors and you wanna make sure that you didn't make a mistake before you turn in your test, sometimes I will check that everything lines up, and I'll use one of the formulas to be able to figure out that. But that's when you get to more complicated circuits. This one is a simple circuit, so I just showed you that it has to work, right? It can't just be something that if I insert those values into the formula, it's gonna give me like 48. It has to make sense. Any other questions?
Is this when you build a new system, a new electrical system? Let's say I'm building a house, and then so I need to install electricity?
You have to understand what happens to amperage if you're wiring it in parallel. Now remember, all of our circuits are wired in parallel in a house. So I have a circuit that has 20 amps, right? The circuit is 20 amps. The wire is rated for 20 amps. That's the max of amperage that can flow through that wire. If I'm gonna be connecting a load to it, that load cannot exceed the amperage of that wire. If I'm gonna be connecting 2 loads to it and they're connected in parallel, 3 loads to it and they're connected in parallel, what's gonna happen to the amperage? It adds up. It adds up, right? So we have to remember the rules for our parallel circuits, and that our amperage adds up and that our voltage is constant, so that we can go ahead and have a balanced circuit, because if not, our wires are gonna overheat. Yeah, so this is something that we have to always take into consideration. So for example, when my students are wiring for a bathroom and they have multiple loads that they have to connect to a circuit, if they understand Ohm's law and they understand circuits, they did their load calculation. If they just ran a circuit and they put all 4 loads on one circuit, I will tell them, why did you run only one circuit? Oh, well, my lights turned on, my fan turned on, my exhaust turned on. I said, yeah, but you're overheating the circuit because you didn't take into consideration that all of the amperages used on the circuit are gonna add up. And this is something that as electricians we need to know. And we need to always remember what happens to our circuits when we wire it a certain way. Now, people that do low voltage or electronics, they're gonna be wiring in parallel, in series and in combination. But as electricians, most of the time we wire just in parallel. Okay?
Thanks.
For residential, for commercial and industrial, we wire in parallel. Okay, so let's go ahead and do one more exercise. And we're going to talk about formula number 4. Now, does anybody have any questions on formula 1, 2, or 3? No?
No.
Alright, formula number 4. For formula number 4, it's Rx. X meaning that we're missing a value, right? We're missing one of the resistor values. but we have our total. So it would be 1 divided by 1 over our total. Now, our total always has to be in this position. If you go ahead and you put it in another place, then you're gonna have a wrong answer. Minus 1 divided by R1, minus 1 divided by R2, minus 1 divided by R3, and minus 1 divided by R. N is the number of resistors that you might have in the circuit. So if I have my total and I have the other resistor values, but I'm just missing one, I can use this formula, insert it into the operation, and then I'm gonna go ahead and have a circuit. So I'll give myself some space. Okay, so for example here, let's say that my, we've got here 10 ohms, we have 5 ohms here, and my R total is 2 ohms. So in order to be able to insert our formula number 4, we have to be missing a resistor value. So here, I would say R total equals 1 over the value of my total resistance, which would be 2, minus 1 over 10, minus 1 over 5. 1 divided by 1 over 2, which would be 0.5, if I'm not mistaken. Just my calculator. Point 5 minus 0.1 minus 0.2. So I have to do this in order. One of the mistakes that I see a lot when the students are solving this is that they'll put the values wherever. But this total has to be in the front. So this is my R total. And then we have to go ahead and subtract. If not, you get a negative number. So now I'm gonna take Rx equals 0.5 minus 0.1 minus 0.2, which would give me 1 divided by 0.2. My missing resistor would be 1 divided by 0.2. It would be 5 ohms. So we would enter right here 5 ohms of resistance. And this is how we use our formula number 4. Yes.
It's only used when there's a missing resistor?
only when we have a missing resistor, and we have to have all of the rest of the resistor values. If you have 2 missing resistors, you can't use it. You have to have only 1 missing resistor, and if you don't have the R total, you can't use it either. Okay, so you have to have your R total, because your R total is gonna go in the first place right here, and then we're gonna subtract the reciprocal of the other resistors that we have. Alright,
Okay, on step number 2, you got 0.2, right?
mm-hmm,
You got that number from the total resistors or?
1 divided by 5.
R3.
That's R3.
So you have to do this, so first you have to divide here
Yeah.
in this step. So you take 1 divided by 2, 1 divided by 10, 1 divided by 5, and then here you're gonna subtract. In this step right here, you're gonna subtract these numbers, and then here you're gonna divide again. 1 divided by the answer of that subtraction.
But in formula, over here in the bottom, you put the R and like the total of resistors or not, the last?
Whatever number of resistors you have. Doesn't matter if you have 4, 5, 10, it's in.
Oh, yeah, this, okay.
Mhm. A switch, and that switch is gonna turn on 3 lights. Now I'm gonna wire these lights in parallel. So I'm going to go ahead and send my power up to the lights, but before they go up to the light, they're gonna be interrupted right here by this switch. So this wire right here is our power. This wire right here is our white wire, the one that closes our circuit, the one that's called the neutral. And these right here are going to be our lights. So these resistors, resistor number 1, resistor number 2, and resistor number 3 could possibly be 60-watt light bulbs, right? 3 60-watt light bulbs. And I'm gonna wire them in parallel, so each one of them is going to be getting the pressure that I'm gonna apply to the circuit. Now, most of our circuits receive 120 volts. So I will be sending 120 volts to all of the lights. That's going to be a constant pressure that each one of them is going to get. Now, because all of them have the same resistance value, or the same wattage, then I'm assuming that they're all gonna have the same resistance, right? It's gonna be the same throughout the whole circuit. So, I'm gonna go ahead and bring my circuit, my first circuit, and this is going to be a 14-2. Now, last week we talked about what is a 14-2. These are going to be the wires that we're running in residential. And in a 14-2, we have a white conductor. I'm gonna color code it. That white conductor is going to be our neutral. And that neutral is gonna go right here to the light. But before we connect it to the light, we have to make a splice because it's gonna go also to the next light. And this is what we call parallel, because we have our neutral coming in, right, from the home run. And then we have our neutral going into the next light, but also connecting to our second light. Our neutral coming right here from the power source, and then going in directly to the last light. So this is a parallel connection. Then we have to interrupt our power with the switch, because we want the lights to turn on only when I turn on that switch. So I bring the power directly to the switch, and then from the switch, I'm gonna go in, and I'm also going to make a splice where I'm going to be sending power to the next light, right? And through this splice, I'm going to make the splice right here. Through this splice, I'm gonna be sending power to this light, and through this splice, I'm gonna be sending power to the next light. So this allows 120 volts to come to the first light, 120 volts to come to the second light, and 120 volts to come to the third light. They're all receiving the same amount of pressure, so all of them will be bright. They're receiving the full potential of the circuit. They're giving very little resistance to the flow of current, so our lights are actually very, very bright. And this is the same thing as our drawing that we have up there. And by knowing this, I could figure out how many amps are flowing through that light using Ohm's law. So what would be the total amperage, the total power, and the total resistance of the circuit? Go ahead and solve it using Ohm's law.